First, we have Andy Hanner, lead meteorologist and fire weather program leader for the National Weather Service in Tallahassee, here to give us a fire weather update.
Hey, good morning, everybody. Like Chris said, I'm Andy Hayner from the National Weather Service here in Tallahassee. And so I'm a member of the fire weather team. Just want to point out Wright Dobbs, yep, raised his hand. He's also from the Weather Service in Tallahassee, part of our fire weather team. And then my predecessor, Tim Barry. I'm sure that a lot of you probably know him better than me. He was obviously the fire weather program leader at the Weather Service in Tallahassee before I was. So anyway, without further ado, I've got 40 minutes of time here. So I'm going to spend probably about the first 20 to 25 minutes of time just talking about weather and El Nino, things like that. And then the second half of the time will be spent talking a little more about programmatic type things related to the fire weather program. So yeah, that's basically, I just described the outline. And so as far as fire season in Florida goes, before I really launch into talking about current weather, I always just have to pop up the climatology. It's funny, like 15 or 20 years ago, there was a survey that was done of fire managers across the nation that asked, what do you consider to be critical fire weather, from a wildfire standpoint? And the answer, overwhelmingly, and perhaps not surprisingly, was hot, dry, and windy weather. So, here in North Florida, that's the kind of weather we get behind our so-called cold fronts late in the spring, like in May. You get one of those so-called cold fronts come through, and it gets dry and it gets windy behind the front, but it's really not that cold. If anything, those are the days when you get 90 degrees, RH down 20%, and the wind is gusting 25 to 30 miles an hour. So yeah, here in North Florida, you see where I've got that boxed in there, May through early June. And then as you move down the peninsula, down towards central Florida, the peak of the hot, dry, windy conditions comes a little earlier than it does up here. They start to moisten up and their rainy season starts sooner down in South Florida than it does up here. And so the peak of their, I would say, maybe not even so much fire season, but at least wildfire weather conditions comes more like early May. Okay, so now let's launch into a review of the weather that we've been experiencing, at least since the start of the year. So as you, look at the big scale picture, this was the month of January. And for the most part, much of the Southeast, especially as you move out west of here, had, and this map, what you're looking at is, percent of normal rainfall, which, during our winter months, what's normal is we get a cold front come through about once a week. We normally get about half an inch to an inch of rain every single week. Gulf Coast obviously is a moist place. So if we're not getting a half inch to an inch of rain every single week, we're starting to get behind on rainfall. But if we're getting at least that much rain or more, then we're keeping up or getting ahead. So you can see, locations out west of here, especially as you move out across Louisiana, Mississippi, even most of Alabama was getting ahead of the game for the month of January. Certainly there was a large area down in Central and South Florida that was getting ahead of the game in January. But then there were definitely areas that were just barely keeping up or maybe not quite keeping up on rainfall. And as we zoom in more to North Florida, the area that, draws this crowd here, basically the Forgotten Coast really was the winner in January. And then you move out places like Santa Rosa County, Crestview up to Dothan, Alabama, man, they got a lot of rain over there. So now moving forward to February, there were more places in February that missed out on the rain, especially areas over here east of Tallahassee, more into the Big Bend, over up to Valdosta. I know the far western panhandle and southwest Alabama really missed out on the rain. They ended up, I think, in late February with, some pretty sizable wildfires over there, especially over in Baldwin County, Alabama. So just across the Perdido River from Escambia County, Florida. And zooming into the area that draws most of our folks, once again, you can see the main area that actually kept up on rainfall was out around Panama City, up to Chipley, Bonifay, maybe as far west as Defuniak Springs. They kept up over there, but most of the area got a little further behind in the month of February. So now, finally, moving forward to March, the month that we're in, looking at the big picture, boy, South Florida, this actually does include the rain that came this past Saturday. They just got clobbered with heavy rain down there in South Florida. So man, considering it's heading into the peak of what's normally the dry season in South Florida, I expect the swamps in South Florida are pretty full heading into the start of April. But zooming into North Florida, the most recent rainfall, we got a good slug of rain from Apalachicola up to, I'll say, Crawfordville. And then I know I live over here in Northeast Tallahassee. We got about 3 inches of rain at my place. And that swath of rain extended all the way across northern Jefferson, northern Madison County over to Valdosta. The inland panhandle has gotten ahead on rainfall in recent weeks. But if you zoom in on the areas that have kind of missed out or maybe not quite kept up, we're talking Bay County over in the Panama City area, some of the southeast Big Bend, the northern Nature Coast, so areas as you get south of Perry down toward Cross City and Chiefland. This actually is just a zoomed in map showing the rainfall totals from this most recent rainfall event. So basically this past Saturday, and once again, you see that stripe of rain that happened from about Port St. Joe up to Tallahassee and over to Valdosta. There were places in there that got, 2 to 4 inches of rain. Most other places, quarter to half inch. That's not quite going to keep you up compared to what we normally see in the winter. So here's the latest Keach Byram Drought Index, which shows, the soil moisture for North Florida. We're in good shape soil moisture wise. What's interesting, normally by this point in the spring, I expect South Florida to really be lit up, with those values over 500, 600, even 700 based on what I've seen in recent years. But you can see really about the main part of the state, once you get south of I-4, that has missed out on rainfall consistently this year has been the coast of East Central Florida, basically from Cape Canaveral down to about Fort Pierce, Jupiter, down that way. So that seems to be the one part of the state that has consistently, over the course of this winter, missed out on the rainfall. So here's the latest drought monitor map for the nation. Obviously, there's not too much to focus on here in Florida. I know there are definitely, especially our federal folks in here, y'all are looking probably to head out west this summer. And what I can say about what you're seeing out west of the Mississippi River, the drought status in the Southwest this winter has pretty much been holding steady. There's been very little change. They entered this winter with drought, but they've gotten kind of a normal amount of rain and snow. And so they've been basically holding about the same. But the northern Rockies, especially you get up into Idaho, Montana, over into the northern plains, Minnesota, northern Wisconsin, the UP of Michigan, those places have been adding on to their drought this winter. They have not been getting the snow that they usually count on to, build up the snowpack and basically moisten the environment. So here in Florida, the one place that still has even that D0 designation, what we consider an abnormally dry designation, is around the Tampa Bay area, especially Pinellas County down along the coast of Manatee and Sarasota counties. That actually is a holdover from the super dry summer that they had last year. You might remember with westerly blow last summer, the immediate coast down there was just missing out on all the summer thunderstorms. They were forming inland and then moving off to the East Coast. So as we exited last summer, that part of Florida was in exceptional drought, that highest level of drought. So what you see here, the D0 is actually an improvement since last summer. Okay, so now this is a map showing the forecast rainfall moving out over the next 7 days. So from now all the way through, I think about Monday of next week. And what you're seeing, obviously, is a good bit of rain, especially up here in North Florida. The swamps down to South Florida, the Everglades, they may finally have a chance to, dry out a little bit. I don't know, it always takes a while to dry out down there once it gets wet. But up here, we're looking at a few places that could be in that, 3 to 5 inch rainfall amounts, basically. So it looks like there will be hardly any place that doesn't get at least 1.5 inches of rain over the next week. So basically, most places this week are going to be keeping up or getting a little bit ahead on rainfall. This is the 8 to 14 day climate outlook. So now we're looking 1 to 2 weeks out into the future, basically the first week of April, April 1st through the 7th. And the climate outlook calls for odds slightly leaning toward above normal temperatures. To me, that's not a very strong signal. And then as far as rainfall goes, odds somewhat leaning toward above normal rainfall. So, all indications are over the next 2 weeks, we're going to be keeping up or getting a little bit ahead on rainfall. And then this is the 3 to 4 week outlook. So this is basically looking at the second and third weeks of April. And the outlook continues to call for odds leaning toward above normal rainfall. Okay, so now I'm going to shift our focus from what's been going on and over the next 2 to 3 weeks to kind of the bigger climate picture, especially in reference to El Nino and La Nina. Those two climate signals we collectively refer to as ENSO, or the El Nino Southern Oscillation. I won't throw that term out again. We'll just be talking about La Nina and El Nino. For those who don't know, El Nino and La Nina basically describe the state of the sea surface temperature out across the equatorial Eastern Pacific. And it's interesting because, sometimes those waters get cold, sometimes they get warm. And if you think about how much energy goes into simply boiling, a big pasta pot on your stovetop, and how much energy gets released out of the water, from that pot of pasta on your stovetop. Think about the water temperature across a swath of the ocean, thousands of miles long, increasing by 1, 2, or 3 degrees, and how much energy gets released into the atmosphere, with just these small changes in water temperature. Though the release of energy into the atmosphere actually affects weather patterns around the entire globe. And so, of course, here in the Southeast US, we're no exception. Our weather patterns get impacted. So anyway, El Nino is the state where the water temperatures in the equatorial East Pacific are warmer than normal. And the opposite of that is La Nina, where those waters are colder than normal. So with that explanation aside, what we see here, this is basically a graph that shows, it basically graphs El Nino and La Nina. If you see the line above, that dotted red line, basically we're into a state of El Nino. And this past winter, we were in a state of strong El Nino. This was the strongest El Nino we've seen in quite a few years. And the weather pattern this winter just was pretty classic for a strong El Nino. You can see that line, just in the last couple months, has started to drop. Before we get to where it's going, just want to pop up this graph showing, again, just your typical El Nino pattern, which for the Southeast US, basically brings a cool and wet winter. Usually there's a lack of temperature extremes during an El Nino. It's unlikely that you're going to get that deep freeze. And sure, we got cold mornings and frosty mornings this past winter, which is normal for North Florida. But we didn't get down to like 13 degrees like we did the winter before, for example. So I think Tallahassee, if my memory is right, I think the coldest we got all winter was 23 degrees. So, by Tallahassee standards, that's not too bad. And so, El Nino, though it's weakening, it's still going to be impacting the weather here in the Southeast US for the rest of spring. So basically, the outlook calls for odds pretty well leaning toward above normal rainfall through the month of June. And this is just the state of drought. Obviously, we don't really have drought here in Florida. You'll see drought continue to worsen across the northern Rockies, the northern plains, and improve basically for the central plains and the mid-Mississippi Valley. Okay, so now these are the official wildland fire potential outlooks that are put together by the meteorologists at the different geographic area coordination centers around the country. They're putting together weather, fuels, and all kinds of intel to come up with these outlooks. So for the month of April, they're forecasting below normal significant wildland fire potential. And by significant wildland fire potential, they're actually trying to basically forecast, conditions that will get you large wildfires, like 95th percentile wildfires that are a big draw on resources and become very expensive. So that's really what they've got their focus on. And so they're calling for below normal potential for those kinds of fires in Florida through the month of April. As we move out into May, they're not seeing as much of a signal that would make them lean one way or the other, above or below. So they're just calling for near normal significant wildland fire potential. And as we move out into the month of June, basically same thing. So to me, this implies that they're looking at perhaps an on-time start to the summer rainy season. But basically, there's just not enough signal moving out into May and June. Maybe above normal rainfall, but with above normal temperatures, maybe those two factors kind of balance out each other. Okay, so we were talking about El Nino a bit ago. And I kind of foreshadowed the fact that, we'd be looking at what's going to be happening. And this is probably more than even our day-to-day weather in the summer. This is going to be what I'm about to show you could be significant to our upcoming hurricane season. What you're looking at is over the last few months, the red bar up there basically shows the strong El Nino that we're coming out of. But then where you see those blue bars moving out, especially as we get into summer, that is the quick, rapid development of La Nina. In my memory, at least, I can hardly remember seeing such a quick transition between El Nino and La Nina. And so this transition to La Nina is supposed to happen basically just as we enter the summer months and we enter hurricane season. And so let's talk about hurricane season. This is just a map showing the typical influence of La Nina on hurricane seasons. Of course, we have the Atlantic hurricane basin that includes the Atlantic Ocean, the Gulf of Mexico, and then you have the Pacific hurricane basin that, is basically for where hurricanes develop pretty much anywhere west of North America. So what we care about, of course, the most is the Atlantic and Gulf of Mexico. And La Nina typically brings more hurricanes due to weaker vertical wind shear and trade winds and less atmospheric stability. In other words, if you have less stability, that means it's typically more unstable. So just the climate signal that we're seeing favors an active hurricane season. This is just a graph showing the average of all sea surface temperatures across the basically across the Atlantic Ocean, the North Atlantic, between the equator and 60 degrees north, and from the west coast of Africa all the way out as far west as about the Bahamas. And what you're seeing here, that black line coming in from the left, that's higher than all the other lines, that's the way the sea surface temperature has been tracking since the start of the year, I believe. Yep, that's right. And you can see that sea surface temperatures are at a record. The orange line that you saw before, those were the record values that were being seen last year. And despite the fact that we have El Nino last hurricane season, which typically makes for a quieter hurricane season, pretty much that was balanced out by the effect of the warm sea surface temperature. So I hate to be up here and painting a picture of doom, but I think you're probably getting a picture of doom here. We're talking about La Nina coming, which typically, all other things being equal, enhances the hurricane season. And then we're looking at values like water temperatures across the Atlantic on average right now that are where they usually are in the middle of May, not the middle to late March. Okay, so with that said, here is the climate outlook for the months of July through September. And the main thing I want to point out here is this broad swath of above normal rainfall from the coast of Texas all the way up the east coast of the US. And my hunch is that this is probably some sort of reflection or signal of increased tropical activity as we head out, especially into August and September, the more active months of hurricane season. So for those, especially, so for those who typically head west to the western US for wildfires in the summer, the signal I want to point out here is odds favoring below normal rainfall for pretty much all but the very western part of the West Coast. There we go. I think I'm a step forward, a little less feedback. But anyway, typically what I get out of this is, the large majority of your big fires out west are started by lightning. Certainly there's the human caused aspect as well, but your large fires by and large are caused by lightning from thunderstorms. So, from the years that I spent out west, what I noticed was that if you had below normal rainfall in the summer, that meant below normal thunderstorm activity, and therefore below normal lightning and below normal ignitions. So maybe that's the one, if you like going out west for overtime, maybe this is bad news. If you like staying home, perhaps this is good news. Okay, so here's the summary, basically the first half of this talk, and that is that through April, we're looking for below normal fire potential, and then fire potential is expected to be near normal in May and June. And though the hurricane season, the official hurricane season outlooks don't get issued till about May 20th, based on what I'm seeing so far, I'm counting on those hurricane season outlooks to point to an above normal season. Okay, let's see. Okay, 9:28, got 12 minutes left, so we're in good shape here. Okay, so now we're gonna shift more into programmatic things related to the National Weather Service. I'm sure many of you are well familiar with our spot forecast webpage. We've had the current version of the spot forecast webpage, gosh, going back 20 years or so, I'll say. But some changes are coming. In fact, the National Weather Service Director, his name is Ken Graham. He's been on the job as Weather Service Director now for about a year and a half. This is a picture of him and our Assistant Director on the left. They're trying out their Eclipse glasses. they're getting excited. So anyway, that's Ken Graham. But ever since he came in as the Weather Service Director, he has had a well-known top 10 priority list that is known as Ken's 10. And so these are areas that he's focused on, that the Weather Service is considering a high priority. And so one of Ken's 10 is to migrate the National Weather Service spot forecast page, quote unquote, to the integrated dissemination program, which will increase reliability, functionality, and supportability of the application. So I don't expect y'all to really care what the integrated dissemination program is, but ultimately, they're going to be shifting the spot forecast page over to. I'm not so much a computer guy, but I know that it's going to be housed on a different web server. I think the integrated dissemination program, that's the area of the Weather Service that's getting more into cloud computing and making our web services more reliable by putting stuff out on the cloud. So I know that there's going to be kind of a modernization, a freshening of the spot forecast page, and it's basically going to be put on a platform and overseen by folks that will make it more reliable. There will be a slightly different look and feel to it. I haven't seen any prototypes yet, but this change is coming. In fact, here's the timeline. They've already, I know the folks who are overseeing this have already tested the new page that was supposedly finished on March 4th. The computer code related to all of this was frozen on March 11th. And so the spot forecast page, as we know it, is going to change by June 30th. So this was the latest I heard as of about 2 weeks ago. Okay, so the next programmatic thing to get into is our red flag warning program. So what you see here on the left is basically the red flag warning criteria for the state of Florida before 2024. To get a red flag warning, we basically need a certain relative humidity criteria concurrent with or occurring at the same time as a certain wind threshold, which is about 15 miles an hour sustained, concurrent with a certain level of fuel dryness. In fact, I call that level of fuel dryness kind of a prerequisite. We don't even consider red flag warnings until we until we hit a certain level of fuel dryness, which in the past we have tied that to an ERC level. So going by ERC in recent years has become problematic for us. It seems like with each new version of NFDRS, the National Fire Danger Rating System, you know, the systems through which we get ERC data would change and update, and sometimes we would go, you know, again, we're meteorologists, not fuel specialists, so we would go sometimes months without really being able to access the ERC data from the usual sources that we had. So partly to counteract this, we have gone for, and this is not just the office in Tallahassee, but the whole state of Florida. This year, with the update to our annual fire weather operating plan, we have gone to using the significant fire potential outlook. This is a day-by-day outlook that goes out 7 days into the future. And so now that fuels prerequisite, we're going to be using the brown or moderate category. The folks who produce these significant fire potential outlooks are the 2 meteorologists who work at the Geographic Area Coordination Center up in Atlanta. They are putting these outlooks out for the entire southern area, which stretches from Texas to the Carolinas. And so, you know, these folks, I mean, whereas our day-to-day job is basically forecasting weather and doing forecasts and weather warnings, their day-to-day job is actually looking at fuels. They've statistically correlated, you know, different levels of fuel dryness to large fire occurrence. And so, in fact, this is just a little flow chart. I think this chart is probably like over 10 years old. It's probably even better now than what I'm showing here. But basically, a lot of the inputs that go into the significant fire potential outlook. So, I mean, there's multiple measures of fuel moisture. There are some aspects of weather that go into this. So this is not a true fuels forecast. It's not a true weather forecast. It is it's literally a significant fire potential outlook. They're basically, of course, what they care about up at the GAC are anticipating, you know, the need for large scale resource movements, you know, from state to state or forest to forest, you know, things that become expensive, basically. And so, so with these categories that ultimately you get down at the bottom, you've got the green moist category, the yellow dry category, and the brown very dry category, you know, the moderate brown category. You know, ultimately what's behind these colors are percents, you know, percent chances of getting a new large fire. So I think with the green or moist, it's less than 1% chance of getting a new large fire, you know, over a pretty large area that they call a let's see, predictive service area. So had a little rain hiccup there, but anyway, so once you get up to those high risk designations, the orange and the red, that literally means that there's a 20% chance or better of getting a new large fire in one of their predictive service areas based on the fuels, the weather, and perhaps some sort of ignition trigger. Here in the Southeast, it's usually the same kind of conditions that, you know, that we associate with red flag warnings, you know, really hot, dry, windy conditions. Out in the Western US, it might be a lot of, it might be an increase in the ignition triggers, for example, from lightning. You can certainly get that in the Southeast, but I classically think of that more out in the Western US. So anyway, this is now what we're going to use as that prerequisite that we need to be seeing. We're looking for those brown values or the high risk values before we're even really going to consider a red flag warning. This is just an example that I pulled off the internet last Friday showing a map of the Southeast US and the large fire potential for late this week. Right now, obviously, it's pretty low. And so once again, our updated red flag criteria, we're not changing the weather that's behind this. We're just changing that fuels prerequisite to the significant fire potential outlook. Okay, so more programmatic stuff. The National Weather Service is in the process of eliminating lightning activity level and Haynes index from fire weather forecast by January 1st of next year. And you might be saying, but why? Well, here's why. Ultimately, lightning activity level is redundant. That's the big reason why. Lightning activity level, the numbers that you hear for lightning activity level, they just describe the coverage of thunderstorms that we're forecasting, which is something that's already mentioned in the forecast. So for example, if we're forecasting isolated thunderstorms, that goes with an LAL2. And so, but you know, you're probably already hearing isolated thunderstorms. So it's completely redundant to what's in there. And then of course, I know out west, LAL6 is really problematic for communicating. You know, LAL6, you'll never hear it in Florida, first of all. But LAL6 is basically scattered dry thunderstorms. Most of the time, even out west, if you start off with scattered dry thunderstorms, you know, they're going to moisten up and become wet. So, you know, 6 has always been problematic, but ultimately it's redundant. The information is already there in the forecast, and it's just one more number to kind of clutter up your memory, basically. Okay, the elimination of Haynes index. Haynes index is not used in Florida, so I don't want to really belabor this point much. But Haynes index basically represents a layer that's 5,000 to 10,000 feet off the ground. If you're talking mid-level Haynes index, and high-level Haynes index represents a layer that's 10,000 feet or more off the ground. Many times this is completely irrelevant to what's going on the ground, where we actually care about, where fires, where our burns are taking place or the wildfires are burning. In fact, here's an example. How deeply does surface air mix? How deep is your mixed layer on a summer afternoon? And let's see, so at the coast on a typical summer afternoon, the mixed layer may only extend up to about 3,000 feet. It doesn't even extend into that layer about 5,000 feet. And as you get inland, maybe then you're talking about approaching 5,000 feet on a typical summer day. So what happens above 10,000 feet stays above 10,000 feet, completely useless. So we're going to get rid of that. If you go out west and you hear the term Haynes index, this may be the last summer that you hear that term. And last but not least, I just want to briefly touch on my pet peeve watch out situation, which is watch out situation number 15, wind increases and or changes in direction. And so what I'm going to show you here is really what I'm going to get to here. I'm going to show you some radar imagery, and I want to get your eye tuned in to what you should be looking at in radar imagery when you've got fire on the ground. Of course, with a typical summer thunderstorm in Florida, we get rain falling down through the storm, and just like a waterfall drags air down with it, you know, you feel the breeze at the bottom of the waterfall. It drags air down with it. That rain cool air hits the ground and then spreads out in all directions. So, and where the leading edge of those outflow winds are located, we call the gust front. So from a fire standpoint, you know, if you look at the aspects of the weather that get fire practitioners in trouble, whether it's a prescribed fire or a wildfire, it's that watch out situation number 15, wind increases and or changes in direction. And that certainly applies where you get the cold, gusty outflow winds passing your fire. So I'm going to show you about 5 radar images here. Just to, again, just get your eye tuned into the right thing, looking for the right thing in radar. So here's an image, classic textbook example, where you've got, you know, a cluster of thunderstorms. I think to most people, your eye would just naturally be drawn to the, you know, the reds, the oranges, the yellows. Oops, it advanced by itself. I think your eye would naturally be drawn to the reds, oranges, and yellow, but that's where the heavy rain and maybe the hail is located. As a fire practitioner, practitioner, what your eye should be drawn to is this fine line that, if we were to animate this, would be spreading out in all directions away from the main core of, rain and perhaps hail. And so, this fine line is what you should be watching, because that's the leading edge of the gusty outflow winds coming out and away from your thunderstorm. Here's an example from, actually this is from Arizona, the day of the Yarnell Hill tragedy back in 2013. And, in this radar image, you see all these little fine lines. This is off the Flagstaff, Arizona radar. So again, those fine lines, that's where those gusty outflow winds, kind of the leading edge of those, are located. Here's an example from the high plains. Once again, your eye may be drawn to the yellows and reds up here, but what your eye in the fire environment should be drawn to are these fine lines that are spreading out and away. That's the leading edge of your gusty outflow winds. One more, well, I've got 2 or 3 more examples here. I'll try to make them quick. But anyway, you've got your storms. This is actually near Denver. Classic example. The fine line is spreading out away from these small storms. And so that's where the wind shift is. Actually, this was a fire in Northern California. I was actually on that as an incident meteorologist back in 2014. Your fire is burning right here. You can see the prevailing winds were out of the south. At the start of this loop, the smoke was heading off to the south. You've got some thunderstorms off to the east, and what I'm going to show you, I'll loop this one more time.
We got a couple minutes for questions. Randy, you got everything? Anybody?
I just, I was thinking back.
Hold on a second.
Just thinking back to, I believe it was 1980 or 81 when, they had some fire crew at Merritt Island Refuge was working a wildfire close to the launch site. And they got hung up on the stump and then had a thunderstorm come in there. And they were focused on getting the plow loose, and fire came from the opposite direction and burned, and both people died. And, we had a fire at East Point that got out from a thunderstorm that was blowing 60 or 70 miles an hour in June come from the north, which is, you don't see that anymore. But those, that watch out 13 when the winds change and increase, the direction changes. I think that's important to stress.
Yeah.
Thanks, Doug. Repeat it for the folks on the room. Yeah, the question comment was mainly reinforcing the need to be on the lookout for those wind shifts, referencing the Ransom Road fire in the early 80s at Merritt Island, as well as other ones in North Florida. that up to 60-mile-an-hour wind shifts. And do you have anything you want to add as far as reinforcement?
Yeah, actually, the one radar loop I didn't show, just for the sake of time, was the Sebastian prescribed fire burnover back in the early 2000s. Again, that was a case where, obviously, that was back before people had radar apps on their phone. I know you've all got them on your phone, which is part of why I bring this here. We're more armchair meteorologists than we've ever been before, especially in a weather savvy group like this. But back then, that was not so much the case. But if you look at the radar loop that day, it was a classic case where you had a cluster of storms move by well to the north. I mean, 40, 50 miles to the north. But you got this outflow wind from those storms that actually showed up pretty nicely on radar that moved well out and away from the storms. It was wintertime, by the way. It was February when that happened. So these were winter storms. But anyway, but yeah, ultimately that passed the fire. They had a 90-degree wind shift, gusts up around 35 to 40 miles an hour. And obviously, in the fire environment, that leads to bad things. And actually, for me, as I've sat and reflected on the Sebastian burnover over the years, one of the things, obviously, we're a Florida crowd in here. The vast majority of the thunderstorms that we go outside and experience, or hopefully actually that you're experiencing from inside your vehicle or looking out the window. Anyway, most of those are summer thunderstorms. And our summer thunderstorms, they come with a lot of lightning. There's a lot of warning, just from a loud, and they tend to move slow. I mean, when I think of a summer thunderstorm in Florida, I usually think of something that you're hearing 30, 40 minutes before it arrives. You've got that much warning to kind of adjust your tactics or to shut down your burn. But with winter thunderstorms, so this is the point of what I'm talking about now, that contrast between winter and summer thunderstorms. You don't get nearly as many winter thunderstorms, but when you do get them, they move a lot faster. If you hear thunder and lightning with a winter thunderstorm, this was late February with the Sebastian burnover, you may have only a couple minutes before the wind shift arrives. They move much faster, and so I think for us Floridians, we're conditioned to slow-moving summer thunderstorms. But in the winter, you have to kind of be thinking of a different mindset as well, that this is going to happen a lot faster than you would expect by hearing the same sound of thunder in the summer.
Mike.
Oh, yeah. Hey.
I got an armchair meteorologist question for you.
Yeah.
So you gave the official forecast for the summer period, looking like it's going to be relatively wet in North Florida.
Mhm.
But looking at some of the Canadian models and maybe others, they're showing a drying period starting pretty soon. Do you have any feelings on that?
Yeah, okay.
Yeah, but the question was, though the outlooks that I showed earlier show wetter than normal conditions, or at least odds leaning toward above normal, really going out all the way from now through the summer. He was pointing out some specific models, the Canadian specifically, that's showing a period of drier weather coming up. And, I guess my answer to that would be, even in the midst of, a 6-month period with above normal rainfall, on average, you're still going to have periods with little, if any, rain. In fact, it's very common in North Florida to get, a 2, 3, even 4-week stretch without rain, from late April out through the middle of May. We don't get the wet cold fronts coming through anymore, but the summer thunderstorm season hasn't started yet. And so, even against the backdrop of, odds leaning above normal rainfall, there's still definitely going to be those periods in there. So, yeah, I would expect, some dry weather in May. Actually, though, with what you're talking about with Canadian, I think it's showing some dry weather in mid-April. So, yeah, I think that's legit. Yeah, anybody else? Yes, sir.
Follow up to the gust flows.
Mhm.
How far out are you seeing those as strong winds in that belt? And do they have the same pressure gradient you get with like a cold front or something, to where it's gonna be calm, or you're gonna feel a wind shift before it hits? Or is this just a straight line that comes, and how far before it falls apart usually?
Yeah, so, the question was, with the, I think you were referencing the thunderstorms that I was looking at earlier. basically how similar are those wind shifts to like cold fronts? With cold fronts, maybe it happens a little more gradually. How does that contrast with what I was showing? And I would say what I was showing with thunderstorm outflow winds, that can happen almost instantaneously. I mean, just in the drop of a hat. And I think that's what makes them all the more dangerous. Even with the Sebastian burnover down in East Central Florida back in the early 2000s, that was a case where the folks up on the northwest end of the fire were suddenly radioing the people on the southeast end of the fire, to say, we just got a big wind, a wind shift. This is based on the report that I read, wasn't there, but anyway, it obviously happened very fast. And I would say that's actually not uncommon of the arrival of these thunderstorm outflows. How long do they last? Once a thunderstorm outflow, especially from one of our late spring summer storms passes your location, the strong winds may last. Unlike a cold front where the strong winds are going to last for a day or two, with these, it may last only 10 or 15 minutes. So, yeah, usually, in fact, in a wind trace, you'll see a big spike up in the wind speed, but then after that, you'll see a big spike down. In fact, many times, once the winds spike back down with a thunderstorm, they can go nearly calm for a time. So that's actually, I appreciate you bringing up that distinction. Yeah.
What's the
Last one.
criteria change as far as who can call and get a spot weather forecast?
That's great.
In the past, as a private sector, we hadn't been able to call and get a spot forecast. Recently, we were told agency on.
Yeah, that's a great question. The question was basically who can get a spot forecast from the National Weather Service. And, of course, first and foremost, our governmental partners, the U.S. Forest Service, Florida Forest Service, our county and city fire departments can get spot forecasts. They can request spot forecasts from us. But if you are a contractor, a private contractor working on behalf of a government agency, such as the Florida Forest Service or the others that I named, you can also request a spot forecast from the National Weather Service. So the way the policy reads, it talks about these government agencies, but then also the contract agents of these same agencies. So, unfortunately, if you're a private landowner working with a private contractor, I would direct you to the fire weather dashboard feature on our website. In fact, you can probably do a web search for like National Weather Service Fire Weather Dashboard. You'll get a lot of the same numbers that you get in a spot forecast. I think part of the value added with the spot forecast is that you get one of our human forecasters writing a discussion, talking about the weather that's going to happen, expressing levels of confidence, expressing sometimes even an alternative outcome. And also, then we know you're out there doing a burn. I wouldn't say it happens often, but if we have a spot forecast and we've interacted with you, then we can also call you back. For example, if we see a thunderstorm outflow boundary coming your way. So anyway, but back really to the question. Did that answer your question about who can? Okay. Excellent. Okay. Well, I'm going to hand it back. I think I've gone a little over time. So thanks for your time.